Okay, again, you're given a graph and you're given the function and you're given an interval. Indicate the transition points. We will look at the graph, but first, let's write down the derivatives, right? So y equals the cosine of x, and this is going to be plus x over 2, right? Let's put down the first derivative. That's going to be minus sine of x plus 1/2. Let's write the second derivative down. And what's that going to be? That's going to be minus the cosine of x, all right? So I'm going to go through a couple different things, but I'm only going to stay on the interval, and I'll look at the graph in a second, between 0 and pi. All right, the first thing I'll do is look at the derivative. And, when does the sine function, and that sine function, I want the sine function for that derivative to be equal to 1/2. And why is that? That's where that would take on a 0. Right? When does the sine take on a half? Well, you look at, reference triangle. And the reference triangle would be 1 over 2. But so this would be root 3. And I'll do degrees first. This would be 30 degrees. But I want to point out, by doing that, I have to realize that the sine function takes on a ratio of 1 over 2 in two different spots between 0 and pi. But the reference is going to be 30 degrees, right? So it's going to be 30 degrees. Now, the other one's going to be the second quadrant. That's between 90 and 180, so 150 degrees, all right? So there's going to be two values now. And again, one is at 30, one is at 150. 30 degrees is going to be pi over 6, and 150 is going to be 5 pi over 6. Now, granted, I'll put them over here, and then 5 pi over 6. All right, so if I were thinking about it, certainly they give me a graph over here. I'm expecting certain behaviors over here. And again, not that I want to do too much detail over here. Let me erase this business over here, by the way. I'm kind of done with that. All right, so I'm expecting to see a curve where something happens at pi over 6 and 5 pi over 6. Let's go to that. And let's put that down now. All right, so I'm making a claim over here that this is a point, and that's going to be pi over 6. I'm just going to write down f of pi over 6 over here. And what's this thing over here? I'm going to say this is a global max on that interval, by the way. It's also a relative max, all right? So I got that one part. I'm going to do this one over here now. And again, someone says, what's that point over there? Well, it's a 5 pi over 6. And then f of 5 pi over 6. Close that out. I got 2 points there. This is a relative minimum, but it's also global on this given interval. All right? Now, let's go back to the other business, and that's the second derivative. Where does the second derivative become 0 between 0 and pi? Well, if you look at the cosine curve looks like this over here between 0 and pi. There's only one spot where it takes on a 0, and that's would be at pi over 2. All right, so what I got, look over here. And pi over 2, again, roughly speaking, I'm not going to say I'm measuring this to a level of accuracy, but pi over 2 and f of pi over 2. By the way, if you're wondering what f is, f of x is cosine of x plus x over 2. I'm not going to compute that, by the way. What's this over here? It's a point of inflection. And why is that? If you look at the curve, it's concave down, and over here it's concave up. All right? Let's look at the key and see how we did. And I hope the key is written up so I can read it. This is problem number 3. Let's see if I did something for number 3. The first thing to do is I wrote the function down. That's over here. I wrote this one down and wrote this one over here. Local maximum occurs at pi over 6. Relative, I got that. Local minimum, 5 pi over 6. That's right over here. It's also global, by the way. And what else did I put down? Point of inflection occurs at pi over 2. as expected. Thank you.